This video will be about radical equations and inequalities. So when we're given a radical equation, the steps to solve it are: first, you isolate the radical. This means that you end up with something like the square root or the cube root of something equals some blob. And there's nothing else on this side except for the radical itself. Then you're going to eliminate the radical by raising to a power. So if this was a square root, then we would raise to the power of 2. And if it was a cube root, we would raise to the power of 3, etc. And finally, you want to check your solutions, because when you square something, you're letting in a lot more numbers than the domain of the square root. So you want to make sure that your solution is not something called an extraneous solution, or a solution that seems like it's correct but does not work when you try to check it. Let's go through these steps with an example to see how it works. So we have our equation here. The first thing we want to do is isolate the radical, and we can do this by adding 10 to both sides. So that gives us the square root of x minus 1 equals 2 plus 10, or 12. Eliminate the radical by raising to a power. In this case, since it's a square root, we're going to square both sides. So we have x minus 1 squared equals 12 squared, or x minus 1 equals 144. And then that means that x equals 145. And last step, check our solution. So negative 10 plus the square root of 145 minus 1, that equals negative 10 plus 12, or 2. And we see that our answer indeed does work. If we have an inequality, things get a bit more complicated. Our first step is to determine the conditions for the domain of the radical. This means that whatever is under the radical has to be greater than or equal to 0. Then, we isolate and eliminate the radical, just as we did for an equation. And finally, step 3, we want to check our solutions by plugging in a number in each interval. I'm going to show this by running through the same example as we did with the equation, except now the equal sign has been replaced by a less than sign. So first, determine conditions for the domain. This means that whatever is under the radical is greater than or equal to 0. So x is greater than or equal to 1. Then isolate and eliminate the radical. So we end up with the square root of x minus 1 is less than 12, or x is less than 145. Now we can draw a number line representing these solutions. So here's 1 and here's 145. And we're saying that our solutions are between 1 and 145. And I'm going to draw a closed circle here to indicate that x can equal 1, and an open circle here to indicate that x cannot equal 145. At this point, the final step is to check a number in each of these intervals to make sure that we got the right solution. So from our first interval here, I'm going to choose a 0. From the second interval, I'll choose a 10, and from the last interval, I'll choose 170. So if I plug in a 0 into our equation, we get negative 10 plus the square root of 0 minus 1, or negative 10 plus the square root of negative 1. And since we cannot take the square root of a negative number, we know that this does not work. If I try to plug in 10, then I get negative 10 plus the square root of 10 minus 1, or negative 10 plus the square root of 9, which is negative 7. And since negative 7 is less than 2, we say that 10 works. Then, if I plug in 170, then I end up with negative 10 plus 13, or 3. And since 3 is not less than 2, I say that this interval also does not work. This means that we have just verified the answer we got previously, and it is in fact true that x is greater than or equal to 1 and less than 145.